Hello, hello. Let's start for the day. Well, last stream for a very long time. Let me turn on the camera. Today we will most likely not do anything productive. I'm terribly sorry if anyone is here for something productive. Not happening today. We will just talk and try to play music on the motor and enjoy yourselves. So, let's make sure our motor spins. Actually, let's make sure our motor not spin. Because what we need to do is we need to attach a bigger motor that will play music for us. And the big boy is prepared. It is here. I think on a bigger motor we will have a nicer sound. So let's attach it to our driver. So it's even with a cap, but I don't think it will be in a way for us today. So let's remove this. We don't need an encoder. We just need to attach our phases. So let's see. Power is off. Very nice, very nice. Let's wait for people to assemble, to arrive. Because I would imagine a few people know that today is the last stream and will come, hopefully. Or not, who knows? Who knows at this point, right? Let's see. So I need to do it a bit wider. One moment. Let's connect this. Hello. Not enough space still. What a sick boy. Let's see. And now? Okay, now we're getting somewhere. We're getting somewhere. Okay. This sounds rigid enough. Feels. Two more to go. This boy. Okay. Very nice, very nice. And this boy as well. So, almost done, almost done. Let me attach it. Okay, so we are attached and we will probably be able to spin the motor. Or rather, we will not spin the motor, we will only use the motor for one purpose and one purpose only, which is playing music. Where is my mouse? Is it somewhere here? Actually, it is. So, let me find our example for playing music, of course. It will be a complete mess, and we will most likely use AI to generate our songs, rather than songs, but song notes. Who knows? Who knows? Let's see what we can do today. It should be in active experiments, I remember. Or I don't remember, actually. Actually, I don't remember. So let's see. H. It doesn't seem like it is here, is it? Actually, let me make it bigger for everyone watching. Like that. So let's see. Encoder, ADC, hierarchy sensorless, functions, DC step response, gravity compensation. And nope, doesn't seem to be the case. So it's not here, right? Or is it? No, it isn't. Okay. So what other options we have? We have our verification tests, and they are was. Where is my music playing example actually? It's in bring up actually? Is it? Oh, it is. Okay, sure, sure. So bring up it is then. Okay. So let's go to our bring up. Mm. I don't even see an option to call it. Anyways, let's go directly. And how is it called? Let's call it like that. Yeah. Because we can write, and does it have anything else? It doesn't for now. So let's see. And what do we have here? 12 volts is quite a lot. So let's start with 6. Or otherwise we may as well blow up something with a motor this size. So anything else? Okay, this looks fine. This looks fine. We don't need encoder here. So we set our vector signs as 6. Then we activate it. Then we do a time delay. We deactivate it. Okay, sure, because we would like to move to a fixed position for music playing for this implementation. All right, this is our song, and this is our song playing. Sure, looks good enough to me. Good enough for our impromptu concert. And let's just turn the power on. Make sure our debugger is attached. Turn on the power. And hello. And let's flash. Oof. Okay, bring up. Back. So let's see. Okay, something is not working. Very nice. Oh, I see. Sure. Because we added this check a few streams ago. Do not forget to change a frequency. So let's quickly fix this. Easy. Apply. Now we should build without problems. Or not. This is not used anymore. Sure. Anything else? Nope. Let's flash our bring up and let's see if it plays music. You probably won't be able to hear it, but let's see if I can hear it first, and then we will improve from there. So let me actually improve also current limit on my power supply, and let's me start it. Probably you haven't heard it good enough. But that was not bad actually. Let me remove let me remove my filters from my microphone actually. It was actually kind of good. Okay, so where is my filter? It's here, so let's put it way lower. Let's actually remove it completely. You will hear probably a lot of noise, but let's try again. Okay, so this is working. Now, how do we get songs to work there? Also, actually, I need to that a message that I get song request from chat. If anyone wants to request a song to be played on the motor, go ahead. So let me actually add a text about it. Text. No new text. Test. Okay, one moment. Taking song requests from chat. Okay, let's see. I need to scale it down slightly. Good enough. Good enough, actually. Like this. Okay. Let's make sure if chat can hear it when microphone is closer to me. Not that well. Okay, I will need to move the microphone closer when we play something, sure. Okay. Actually, also let's try to increase the voltage. Let's see if it will be louder. It should be. But let's try it. Let's try. I'm also sorry for you hearing me breathing because I have no filters on so that you can see, like, hear the music. Let's run it. Oh, shit. Oh, fuck. Oh. Okay, this was interesting. 9 volts seem to be out of my... Holy fuck. Okay, let's not do 9 volts. 9 volts is a bit too much for my power supply. Let's try 7. That was a bit scary. I'm not gonna lie. So let's see, 7 volts, and we are not flashed because... I turned off my microphone. Actually, let me turn... Oh, fuck. I'm sorry for swearing. Let me turn off the music. Background music, and let's play. Okay, it's louder. Okay. I think we had a request from yesterday for a Nyan Cat, and how will we achieve it? I actually will probably generate songs for from Claude. Let's see. Actually, let's make an easy way to add new songs so that we can play songs that were requested before. So how will we do this? We will do it by... Actually, let me put my filters on while we're not playing any songs. Because I would imagine that hearing me breathing is annoying. Okay, one moment. So, good enough, I guess. Let's add an ability to add multiple songs to play. So, let's see. We will add a pointer then. And how do our notes look? They look like this, sure. So, it will be a uint 32. 32 t notes, active notes, and this will be a pointer, of course, and we will put it to whatever we are playing at this particular moment, and we will be able to actually change this in a software, and we also need a rerun functionality, so we don't need to flash every time we play something that already exists, right? Okay. So we need to move those out. Then these are our test nodes. Oh, also we play a wrong pitch because we play a pitch that is 2 times as high as it's supposed to be, given the implementation I have right now. So our active nodes will be nodes frequencies, and this will be this, and we also add one more, and this will be active, and this should be, no, it can be like this because this is a pointer already, and this will be active nodes durations. And this we will take as nodes, node frequency, no, it will be a node duration US, and we will rename it now. And also this variables has to be somewhere here as well. Where is it? Actually, where is it? Oh, it's up here. What is it doing here? Hello. No, this is not nice. Let's just do an array that doesn't have size, and we will make a const variable, and this will be also, no, it will not be a const, and this will not be a const, it will be just a variable. So it will be you insert 2 t node count, and this will be equals to size of r this. Nice. Will it work? I hope so. I hope so. This should be an array. This should not be a pure pointer. Now, so we need to switch our code to actually work from this boy, and this should be then changed to this, and it also will be, no, it will be just like that. What else do we have here? Just like this. And what else? Nothing. Let's test if this change works, so we don't change too many things at the same time. It doesn't, because size of doesn't want to work at, oh no, I'm just a dumbass, of course. Happens to the best of us, I would assume. And initialize discard const qualifier from pointer, sure. Because I don't want this to be const actually. So that we can change it dynamically, let's not make it const, and let's flash it, and hear our song again now. So let's see if it works, or if I'm stupid. Okay, it works. Oh, and it's it reset itself. Sure. Okay, it's reset itself again. Why is it resetting itself actually? What? Very interesting, very interesting. Okay. We have an infinite loop glitch in firmware. What is happening? Actually very interesting. Why are we playing in a loop then? What is going on? Let's see. Let's see here, and this, and what is that, and where is my value? Hello? Where is the value? Rather, what? Actually, Let's put it here. I definitely broke something and I have no idea what exactly. No, let's put it like this rather. So that we can still see it in our live expressions, of course. Okay, the tabulation is broken. Very nice. Fixed. And here as well. Let's refresh again, because this gets annoying quite fast. We definitely need more song requests, or rather, I definitely need to implement an ability to change songs quickly. Okay, so it's playing, just can't hear it. Let me just put my filters a bit lower, but not too low. Okay, you can hear only like separate notes, I guess. Whatever. Raw dog it. No filters today. Okay, it still resets. And why do we reset? Can anyone tell me? Okay, what is this value? Hello? What's the value? Oh, I know why. Because we are resetting microcontroller for whatever the reason. And Oh, and I know why we are resetting the microcontroller, because, oh my god, I know what's happening. No, I don't actually know. Hold on a second. Hold on a second. I actually don't know why we are resetting. Actually, let's run it. 120. Oh, I'm stupid. I'm stupid. Haha. Haha, I'm stupid. Who would have thought? Who would have thought? And why I'm stupid, you may ask? Good question, good question. And the issue is that I need to do this. Or otherwise I get out of bound request. So let's do it again. Let's do it again. Before we all died from listening to too much Mozart at the same time. Let's run it. So we are playing our Mozart song and we have our 30. Da, da, da. No, perfect. We haven't reset, so fixed. Next, let's change this. We changed. Very nice. Let's change this for that. So here and also here. Done. So now we can add more songs. So let's call it Ode to Joy Durations. Yes. And this will be Ode to Joy Notes Hertz. So this is our first song we are currently playing, and these are, no, this has to be here and this has to be here. Okay, very nice. So let's test it final time before we start adding new songs. Of course, when it starts breaking, sure. And this, can I do it in a smart way? I don't think I can, so whatever. Okay. Because this pointer will not be storing array, so I cannot use signs of this pointer, which is annoying, I would imagine. So let's flash it. Let's flash it and let's hear the song again and run. Okay, actually, now that we heard this piece so many times, I actually want to add more. Why is it so short? Okay, so how do we make other songs? We will have to use AI. Unfortunately, I have nothing prepared for today. So let me open my Claude and let's see what Claude can help us with. One moment. Uno momento. So no, I don't want to open it in Visual Studio Code today. Today we will use AI hard. So, mon ami Claude and mon ami Claude, hello, Mr. Claude. Please go into the bring up examples and see the music playing one, and please add an additional song in Nyan Cat 1 at least 30 seconds. Let's see if it works. This was the first request from yesterday, actually. So let's see. Let's see if Nyan Cat works. Mr. Claude, tell me, can you do this? And while Claude is working, so let's go and see the function. Let's fix the frequency discrepancy because we have it. So we might as well fix it. We don't need our debug protocol. We're not working on the debug today. Today we rock. Okay, so what do we do? Note switch duration. And this has to be halved, right? So that we play part of the note like this and part of the note like that. Last note switch time, note switch duration, 2 and we either play, oh, we play at 12 volts actually here. Hello. So this then changes nothing. So we play at 12 volts, which is quite a lot, but whatever. And let's see, I think this is a fix, so the pitch should change. Let's actually flash it and see. So the song should be more sharp, I would imagine. Or I just broke everything, also can happen. It can also happen, so let's see. That was awful. That was actually awful. So the pitch did change, but I think that our modulation type, which is just on and off, is not working here. So let's actually let's implement sinusoidal modulation for song playing. Okay, given that we don't have any requests yet and our Claude still processing my request, let's actually start implementing the code to improve the sound quality of our concert, of course, in real time. And how will we do this? First, let's actually split this function. So let's call our interrupt. Let's enable our interrupt, and to do this, like we will handle this in the interrupt. So how we'll do this? We need another function, and this will be, let's say, example 11, make some noise, IRQ. So what will this IRQ do? So let's go to our actually motor control example and copy some code from there, which is here. And the first piece of code we need is this piece of code, because we would like to call this interrupt. We will have 20 kilohertz that we can use for our note approximation code. Let's close actually everything we don't need. We don't need this, we don't need this and that and this, and we don't need quite a lot of things actually. Let's close everything and open only what we need. So here, we go here, this is nice. So here, in the main, before everything, we enable this part of code. And here, this has to be now global, because I don't want to spend time making nice architecture. Claude is still thinking about the Nyan Cat song. Okay, so all of this code actually has to go to the interrupt now, I would imagine. And we are breaking stuff. Should I just break everything? How will I fix the Nyan Cat stuff if Claude is actually trying to implement it? Like, am I in a way of Claude implementing this actually? I think I am, but whatever. So we also need to copy, what exactly we need to copy? The interrupt handler, and the interrupt handler has to be here, and it has to be in here. Not here, but here. So let's copy all of it, but we will remove most of it actually. So let's do it like this. And now I have a clear picture. So now it's working. So let's actually wait for this to happen. Okay, I don't touch anything because it started changing files. So let's see if our Nyan Cat song will be added successfully. I'm like hands off the wheel. Let's see. The file changed significantly. Let me read the full update version around the music section. Sure. Go ahead, my brother. Okay. So it does something. It eats my tokens. Bon appetit, as they say. So, will you add Nyan Cat? First, the player state is now global, and there is also an RQ function. Let me add Nyan Cat data and function. And function? What function would you like to add, actually? Sure. Okay, so it changed this, and it's also changed something. Let's see. Let's see what it will change as well. So song has seems to be. But why is it defined though? What the hell is this? What? What is happening? What are you doing, brother? Why so much changes? Everything looks correct. The code is clean. The client diagnostic. La, 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 la. Okay, let's see. Let's see what it's done. Example, Nyan can play. Oh, we just created a new function because I was changing this code. I see. Okay, let's just try it. Let's just try it. And we will continue working on our improved sinusoidal modulation, but let's play a Nyancat song for olds in the chat. So let's build it, make sure it builds, of course, first. So let's see, do we have any problems? We kind of do. Because of this part, let's remove this and also remove this and temporarily remove this because none of it, none of it is needed so far. And let's see, do we have other errors? Okay, one moment. Oh my God. So here, oh, I see. And this has to be, oh my God, let's actually remove it as well. Temporarily, we will fix it later. Oh, things keep breaking. Sure, brother, just go away, play the song. Oh, and now it also breaks here. Oh my God. What I've done. Actually, this is a very good default state. Let's copy this here and just add types to everything. So it will be inserted to T. Actually, most of it will be inserted to T, right? Let's quickly fix this before we can play our Nyancat. Active index, active node index, sure. Active node duration, also a uint, and then last duration is also a uint, and active node frequency is also a uint, and node switch duration is also a uint, and then this, and then that. Okay. And why are you not wanting to work? Initializer is not a constant, so let's make it a constant then, because we will not be able to make it otherwise, I would imagine. Oh my God. Actually, let's just make it 0 here. It will still initialize in the function itself, I would imagine, because we just copied this, right? Now it works. So let's see if Nyancat works. Let's flash it. And let me turn my microphone. Bada bing, bada boom. Okay. But this is not Nyancat, right? It's definitely something. Okay, so this was something, but I personally didn't hear the Nyancat motif in there. It was kind of odd. Actually, let's remove this because I didn't like the frequency. Let's try again. And let me, maybe I just don't remember how Nyancat sounds. It sounds like I actually don't remember how Nyancat sounds. We may need to Google to play Nyancat song. Okay, this is actually kinda... Let me... Okay. Okay, stop. Now let's actually hear how Nyan's cat's supposed to be heard. Like, let's go to our Spotify and... Was it close? Was it close actually or not? I cannot tell actually. Okay, okay. Stop. And let's... Okay. Is it Nyan cat? I'm not sure. I'm not sure. Okay, this... it's definitely fast-paced, and it's definitely somewhere around the motif, but not exactly there. Maybe notes are incorrect. Who knows what I done? So, but anyways, before we get our actual first song request, let's keep improving the code quality so that we can use sinusoidal modulation until someone comes with the first song request of the evening. Okay, so while we are at it, let me get back our music. And let's keep going. So what do we need from this interrupt? Actually, we don't need this, we don't need this, and this, and that, and okay, remove this. This is correct, we don't need this. So at this point, we need to add all our music playing logic here. Okay, so this should still work, I would imagine. And if this works, we need to move all of it into here. So how do we do this? Let's just copy paste for now. And let's see what happens. Let's see what breaks. So while loop is definitely not needed in here. So let's remove this one, and let's fix the tabulation. Or at least try to. Oh my god, what I've done. Okay. Okay. Oh my god. Okay. Any moment now, any moment. So this is that, and this is here. So all of it goes one tabulation up. Oh no, now it's fixed. Okay. So we are in an interrupt. So if active node is node index below node count, so after this, if it's else this, we disable our motor. And this should all be a one tabulation up, right? Yes. Okay. So here, current time in microseconds. How do we attend this one? How were we doing this before? Our current time in microseconds is plus 100 here. Okay, so let's assume that we start the song from 0, and that every iteration we actually add not 100 but 25, because we are in an interrupt and we have an interrupt frequency of 20 kilohertz, which says that I have to be a dumbass. It's 50. 50 here, and we don't need a delay because we have an interrupt to handle delay for us. So let's continue. If the current time, microseconds, and last duration update time active more than active node duration, so we need to change node. Right, time to switch the node, so last duration update time, current time. So we will need to add a floating point here, and this actually has to go now that we are working on it. So let's actually remove all of it, and let's just do a dummy delay here so that we can provide a blinking of the LED to see that the motor controller is functioning correctly. So it will be msec to usec, and let's say it will be 1 second duration. And after this, we will GPIO toggle LED 1. So we have our LED blinking implemented correctly, and also fixed ablation here. I have no idea why it broke, but whatever. Okay, so now we will also need to remove this and add an float active phase. And we also, no, sure, like this. So let's assume we start from 0 here during the initialization. Initialization should happen like this. Then, oh, I see what it done. Okay, whatever. Sure. So let's do our initialization before we enable the interrupt. So initialize the song, and let's finish here and go here and paste this, and let's see node counts. This is awful, but I think this has to be this will have to be updated for every song request. Okay, and these are automatically calculated, sure. And also we will initialize our phase, active phase to 0 at this point. Okay, so now, do we need anything else? Let's see. Let's see if we are playing the notes. So changing the notes is fine, but yes, this is what we are doing. So if current time minus last node switch time. Okay, so at this point, this is actually incorrect. So all of it will be gone, daemon. So, oh, this will actually become so simple now. I would imagine that we need to make sure that we have ARM must included. ARM sign F32, of course, was ARM sign F32, and we will take the sign of our active phase, which is where exactly? Where is it? I just can't type it what I'm doing. Active phase, and let's actually make sure that this phase is in radians per second, or as radians to make it clear for everyone what we are working with. Degrees are for alcoholics. So, as my math teacher in school said, and here. And then we modulate our output frequency. Which way do we do this? We do it by doing 3p form plus FOC 3p. Oh my god. Oh, whatever. Let's just copy this one. Okay, whatever. And here, typing was not included in my today's wake up package. So let's say 12 volts with our, okay, how will we treat the phase? Will we allow the motor to actually spin around? I would not say so. So let's make this stationary phase. And how do we actually calculate this? How did we do it before? And why is it? I see. Add it here, and what was this variable around? Oh, it was a constant here. Okay, sure. Sure. So actually, let's keep it like this in the Nyancat example. And let's move it like here to be a global for the general example. Oh my God, and it's constant, of course, sure, whatever. And we will use our, let's say 0.3, and we will multiply this by our result, which will be float current float. Okay, what will it be? Current modulation shift. This is a correct name because we actually doing an amplitude modulation in here for the engineering type watching the stream. Okay, so this should work. This actually will completely obliterate all of it, all of this. We don't need any of it any longer. We just need to calculate phase correctly. Oh, this is actually so much easier than I thought it would be. I hope it works, of course. This is also a question if it works. Who knows? Who knows? So we need to update the nodes, and during the nodes update, we actually need to set our phase step. We also need a phase step. So float the phase step equals to 0.0. Actually, let's not initialize it here. Let's work with our phase step in here because we need to initialize it based on the frequency, active node frequency. So given that we have 20 kilohertz of duration, we need to ensure that frequency is changed. Oh my God, I need to draw. I have an urge to draw. Okay, so here we are. Space. Okay, we have 20 kilohertz, and we have our, let's say, frequency is 330. So how do we calculate the step? So it means like that this period has to be like 1 divided by 330. T equals, which means what exactly? We have to have 330 full rotations, which is 2 pi's in our cycle. So this has to be calculated like this, correct? I think so. And if I'm wrong, we will hear it firsthand. So let's do it. 2 pi, rather m, 2 pi f32, and we divide it by our 20 kilohertz. But this has to be a float. But this should be also active node frequency, converted forcefully to float, of course. Float. And this has to be a float as well, but this is a constant, so we will just do it like this. Okay, so we will also need to do this array calculation every time we are here. So let's see. And if I'm a dumbass, I am a dumbass. Who cares, right? Now, active node index, sure. Okay. Active node duration, active node duration, active node frequency. So let's update our phase with our active node frequency, which changed. And here, for every node, we need to do active phase radiance plus equals to our phase step. And and here, just for the clarity of it, if active phase radiance is bigger than 2 pi, oh my God, m 2 pi, let's just make sure that we subtract 2 pi to not break anything due to overflow. So let's do minus equals m 2 pi. I think this is all that we need to make it play sinusoidally. So let's actually just flash it and see if we can hear our ode to joy. So let's see, ncat nodes, hertz, and ode to joy durations. and the node count will be size of this divided by size of uint32t, so like this. Very nice, very nice. And I think it should work, and we should hear the song right away. And it should be nicer because we use sinusoidal modulation. But I may be a dumbass, who knows, right? Who bloody knows? Let's try. Okay, it doesn't work. Sure, let's fix some issues. Not a big deal, not a big deal. Oh, continue statement with no loop. And what did I mean by this here exactly is that this is a last node, so we probably need to return. And we probably need to stop the motor at this point. Like that. So let's try. Given that we change this, will it work? I don't know, but we will see. Okay, so let me rotate my microphone. Okay, it doesn't work. It doesn't work. And why doesn't it work? Am I stupid? All right, whatever. Let's see. Why are we not working? So let's add a debug variable uint32t counter test. Okay, whatever. 0. And let's increase this here. So let's make sure that this interrupt is getting called by our device. So here, if we don't need to update this, this should go here. Okay. So this is equals to 30, but nothing plays. So let's make sure that our, okay, let's remove this, of course. Let's make sure that our interrupt is getting called. Oh, I know why. I'm just a stupid person. I had to edit. No, I'm not a stupid person, right? Am I? I don't think I am. Oh, I am. I am. Okay. Wait, am I? Yes, I am. I am. I know how to fix this. I'm terribly sorry for being a dumbass. And this is a very easy fix. Where were we? We were here. And let's actually, instead of doing this, let's just do it like that. So this will work. Now we should hear the song. Hopefully. I expect us to hear the song, right? Right? I'm so confident that I will put my microphone back again. Okay, this is... this can be called the song. Okay. This is definitely a beat of sorts. Okay, sure. We also reset microcontroller. Very nice, very nice. What is happening? Who can tell me? Let's see if this variable changes. And also, I definitely have a beat of sorts. This should be from 1 to -1, correct? And if this is from 1 to -1, then nothing here should be particularly broken. But who knows, right? Let's keep fixing our music playing. Let's add it as a global variable, and let's remove this here so that we can observe this as well. We definitely have a beat, but we don't have a song. So let's run it again, and let's see our debug variables to see if I made a mistake. Like, I definitely made a mistake. Let's see where it is. Now, we are in live expressions, and let's run it. Oh, it's died right away. Hello? Hello? Very interesting, very interesting. So Curious. So let's actually lower the voltage temporarily to see. Actually, why did the microcontroller reset? Like, oh, it resets every single iteration. Hello? What? Okay, very interesting. Let's run it again. Okay, it works, but it eats all my currents, actually. Why does it eat all my current? It ate like 4 amps. Hello? What the hell was that? Let's try it again, actually. Okay, I actually think I need to put something vibration damping underneath. One moment, I will go and fetch some foam. We're all foamed up. So, let's do it again. Oh, and it's so much quieter, actually. You can't even hear it. Okay, interesting. So it plays due to my table. Okay. But this is incorrect. We don't supposed to be using so much current. How do I fix this? Why are we using so much current? We were using almost 4 bloody amps. Have I done something wrong? Have I done something wrong? I think I have. I just don't know what I have done wrong. Current modulation shift should be from 1 to -1, so this will be modulating in this, but why are we sending... Actually, what is the resistance of this motor? I have actually no idea. Maybe this motor just is too... But wait a second. Actually, yes, what is the resistance here? Is it written on the body? It isn't. Let's measure it. Let's measure our resistance so that we can adjust our expectations accordingly. A moment. So, what is our phase resistance? Let's turn off our power supply so that it's not in a way of our measurements. Okay. And let's see. You tell me what the value is, because I will not be able to see it. So, what is the mode? The mode is supposed to be... No, it's supposed to be DSR measurement. Yes, right, correct. DSR, okay? So, tell me the number, chat. Tell me the number. I'm touching 1 and I'm touching 2. Was, actually, I think I need to remove it from the connector, so let's do it, because this is an important measurement for us to be able to play music that sounds nice. Let's remove this temporarily. We have both of them clear. So let's eat 1 and let's eat 2. So our DSR value is, oh, it is correct. So it's less than an ohm. Okay. If it's less than an ohm, then on 6 volts, I will have, I will have 6 amperes. What? Okay. But why was it working properly when we had like 12 volts task on, oh, actually, interesting. Now thinking about it, what if we try to play on a smaller motor? Like how loud or not loud will it be? Let's try. Given that no one requests any songs yet, let's try to see our small motor performance. Uno momento, signore. Okay. So, for this, let's unscrew this temporarily. Hello, Mr. Das. How are you doing? We are playing music, and Nyancat is implemented, but it sounds very awkward. It sounds very, very awkward. So, let's see how our small motor sounds. I didn't prepare for stream again because I was running around the whole day preparing for my trip. It always sounds awkward anyway. True. Very true. Very, very true. So today in the bank, they said that they don't. They first checked me for wire fraud if I'm a fraudulent person, and then in the bank they also tried to decline me opening account in euro because I am not from Poland originally. I am emigrated here, and due to sanctions, given that I'm from Belarus, they wanted to decline me an account. But given that I have a business here, they opened it anyways. Okay, so let's see. Let's see how our small motor works. Okay, I blew up my power supply. My power supply doesn't work. Was? Hello? Oh, now it works. Okay. Sure, let's see and let's hear. Okay, some evening Beethoven for you. Okay, so it works, and this motor kinda sounds actually better. So let's try to put more volts through this motor. I think I need to do some amplification of the sound, something that is rattles on the table, so that it rattles from the motor rattling the table. But we will figure it out. We will figure it out as we go. Now, let's push slightly more volts through the motor. And let's try again, actually. Let's just try again. Very nice. So, any song requests? Let's actually try to run Nyancat. Hopefully, possibly, potentially. Let's copy this here instead of this. And let's just run it. us. Hello. What? We have technical technical difficulties. No, not 10 hours. We only have 30 seconds. 30 seconds version. But it doesn't work. Nyancat notes hertz. Frequencies. Durations. Why isn't it working, actually? Like, actually, why isn't it working? Do I need to change anything again? Let's try Ode to Joy one more time, just for my sanity. Da, 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 da. Okay, Ode to Joy works. Why does not Nyancat not working? Okay. So, NoteCan, sure. Phases, sure. And durations are... Wait, what? It has same durations as phases? Okay. AI, what have you done? Brother. I think you made a mistake when making the Nyancat song. Please read the way I've implemented song playing now and add a race for a proper Nyancat implementation. Thank you. Less than 3. Okay. Let's see how fast will it come up with notes for Nyancat. Do I have any other way to generate notes for us to play? I don't know. I have no idea, actually. Ow! Okay, I broke my camera, right? Moment. Okay. Okay. This work? Thank you. So, any notes? Pretty please? Any requests in the chat? Does anyone want any song for us to try to play? Because we will probably have to wait for Claude to generate songs for quite a while, so we we should pile up requests. Okay. Can we also maybe use ChatGPT? Can you give me to see a race? First will be frequencies of a song, and second will be durations of each note. The idea is to play a major note only on a PMSM motor. Please do it for Nyancat for 30 seconds. Okay, Super Mario Bros. Theme song, sure. So let's see which AI will do it faster and more accurately. Okay. And durations, sure. Let's try. Let's see if this ChatGPT beat Claude in Nyancat song generation. So let's see. It will be Unit 32 rather. And melody, it's frequencies, right? It's Nyancat frequencies And C, US. Claude is making a remix, I think. True. Very true. Save. I think Claude tried to write something. Oh my god, it does make a remix. What are you doing, brother? Okay. Let's cook. Let's the Claude cook. It tries to cook, and I was in its way. Let's make Claude cook our Nyan song. Okay, so you removed your own version. Sure, that makes sense. Sure. But you forgot to add the song. Please add the song. Okay. There is more content because I was in its way. Sure, happens to the best of us, I guess. Please, brother Claude, think faster. I pay money for you, actually. Hello? How was your project, Mr. Das? Have you finished it yesterday? You said you were in a rush. I see you added partial array with wrong notes. Let me check the end of the file and fix this. Sure. Whatever. Let me do the final check on this data. Sure. Wrong notes? Okay. Oh no, I haven't finished it yet, but it was has to be finished in 2 weeks. It's going well. Okay, sure. Perfect. Perfect then. So let's see if NyanCat sounds authentic enough. Let's see if NyanCat sounds authentic enough. Okay, so let's flash it. Actually, this is much more than like NyanCat. That wasn't that bad, actually. That was much better. I think implementing sinusoidal modulation was was the right call for song playing. But first, let's also try out our ChatGPT example. Where is my ChatGPT? Let's see what ChatGPT provided for us as notes. Okay, so let's copy paste those here. This can go there. So let's put it here. Those can be uninitialized for now because we initialize them in main anyways. So then let's move it lower here. So this it will be NyanCat notes GPT, and this will be NyanCat durations GPT. Okay, so let's try. Okay, and let's remove this and that and this, and this will be a size of this notes hertz. So this and this will be here, but this will be durations GPT. So let's see if GPT made a better NyanCat than Claude did. We compare your AI tools by how well they generate songs for my motor playing. Okay, sure. Let's put it. Benchmark the AI tool. Yes, exactly. New way, revolutionary way to benchmark AI tools. Like this, and let's also make it like this. And let's see, will it build now? It still doesn't want to build, right? Oh, of course. My bad. Now it builds. Okay, let's see if ChatGPT Nyancat sounds better. Okay, okay. And it died. Was. Hello. All right. Sure. Um, what? What is that? Um, let's reset and see. What? Oh my god. What is happening? Oh, because it's in milliseconds. Okay, and it should be in microseconds. Okay. Sure. It played the song. It just played it 100 like 1,000 times faster than it was supposed to. The song was played. Trust me, trust me, bro. We played the song. How was it? Tell me. Did you like it? Did you like the song? That sounded awesome, right? Okay, loved it. Nice. Let's try it again. What was that actually? What is this song? ChatGPT, what did you give me? Is it actually Nyancat? When looped 4 to 5 times, hello, who do you think I am? Let's Shazam it. Who do you think I am? Give me the hyped version most known. Make durations in US and add all values to the arrays. Don't make me loop anything. Let's see if it fixes. Hype Nyancat. Sure, this looks scary. But it's copied just itself. What the hell? It just copied, but it's not hyped, like, at all. Where is the hype? Brother. I don't see hype in here. Oh, and also I see the error. I see clearly that I am just a dumbass. Okay, so let's see if this is a more hyper version. Doesn't look hype to me from numbers. And let's also copy these numbers. Does it look like hype? Let's try it. Okay. For me, it literally sounded more like Lord of the Rings theme, like that on the flute. Yes, like this one. Work. Single note melody, fixed timing. Okay, sure. Okay, go, do. Work. Okay. But this still looks the same. Hello, why is it repeating 2 times? Okay, I think ChatGPT failed our benchmark, our most advanced AI tool benchmark, which should generate our notes. So we will switch to Claude, I guess. After this test, of course. Okay, let's see. And let's paste it here. It's still Nyan Cat, whatever. So let's hear it. DJ. Nah, that's not it. It's kind of close, but not. So ChatGPT failed. ChatGPT failed me. Let's switch to Claude. So let's remove this. And let's see. Please add an arrays for Lord of the Rings Ost song Lute 1 for at least 30 seconds. So let's see how fast it will work. Let's see. Give me the notes. I hope it will become faster this time, because I haven't changed much in the code. But let's see. Do I need to switch to like more expensive model for this to work faster? I'm not sure. Let's not touch any code. So while we are at it, any questions in the chat? Any requests? Any other songs? We also have a Mario theme request. Maybe something more modern, something more drivey, something more classic. Anything? Anyone? Okay. Yes, Claude will not be fast. Claude will not be fast at all. But at least Claude quality of song, how to call it properly, preparation is better. So let's see what Claude does. Okay. Anyways, while we wait for Claude to create our song, let's talk numbers. Given that this is my last stream for a while, I would like to share numbers if anyone is interested, actually. Or if no one is interested, I will still share it anyways, because I decided to. Okay. So, let's see. Okay. Where are we? Yeah. So, song, are you ready? Song? Okay. So, my first months on Twitch. Let's see the numbers. How did it go? Did it go well? Who knows? Who knows? So we are waiting for the song to be processed and look at my numbers. So I have quite a rough journey for. I actually have no idea like what is considered a rough journey, but I started with like test streams, and then I just tested a few times, and no one was watching me, which is okay, I guess. No worries. And then I just decided whatever, it doesn't work. I actually started opening my stream on 2 devices. So you see the average number here. Let's see, average views. Actually, yes, I had a stream with like 7 almost. Oh, damn, son. But take all these numbers starting from here and subtract 2 because I have my Twitch open on my two devices, so that I have a bit higher position in the searching bar, searching like view for people to jump in and say hello. So I Twitch botted myself with 2 viewers all the time. I am at fault. But yes, I streamed every day, and we have some rough streams. We have some interesting streams. So what else happened this time? I have 29 followers here, but actually I have only 22. So Claude is almost done. So let's see what menus we also have here. If anyone is interested how I'm found by people, actually, I had a few days where like browser page was pushing me hard, no idea why, and a few days when it decided not to. Also, a very interesting thing that most of my viewers are from somewhere, because I'm from Poland, and I tried to not have too many Polish users because I don't speak Polish and I'm not sure it's how embarrassing this is. I tried to do everything in English, but whatever. I still had too many Polish people here. Okay, sure. And also for whatever reason, Indian and Pakistan people were coming along a lot. But yeah, so this is my viewership statistics, if anyone is interested. And we also have our song ready, so let's see the song first. Okay. All right. Sure. So is it done here? Nope. So let's edit. I actually found you on YouTube. I was looking for a bare metal scene, motion stuff. Then I got you what's recommended on my homepage and found you in the Twitch link there. Oh, I see, I see. So my YouTube does the work then. Oh, I can also share my YouTube stats, because actually for a channel that only has VODs, I have too many views. I actually have like 50 views per day for a channel that is like all VODs. And I was like quite shocked that 50 people just click on the videos. I even got one of your shorts too. I see, I see. So I'm popular then. Okay. Hertz here and here. Char notes. Char durations. So let's see how it sounds. Let's hear it rather. Okay. That didn't sound that good, but I think I remember one advice I heard, so let's try it. We need to remove the last like 5% of the note so that we can hear the same note if it's repeated. And let's try it. Okay, I think... No, this will not work because I need to bump this as well. I need to bump this as well. Anything else? Anything else? Anything else? I don't think so. Let's try. Let's try if it sounds better. actually not sure if Claude did the right song. Let's actually look it up on Spotify. um, no, the song name is correct then. But it didn't sound like this at all. Was. Maybe it is a limitation of a single note playing, but it doesn't sound that good actually. Okay. Okay. Please also at Mario Brothers, I guess. What was the request? Super Mario Brothers. Super Mario Bros. Theme song. Okay. Well, this is happening. Let me also share my YouTube stats to see how huge of a creator I am. Okay. So I posted a short. I have no idea what happened to YouTube, but the short kind of blew up, but it also blew up with dislikes. I'm terribly sorry if someone was hit into a face with my short. I didn't mean to. But if we exclude shorts, I was actually doing decently well for whatever reason for quite a while with views. Some people just came to my YouTube to see VODs, I guess. Like some of my VODs have like 60 views. What? People, what are you watching? What are you watching, people? You did. What are you watching, Mr. Das? But yes, it was quite surprising that it was doing so well. I was completely blown up. Actually completely blown up. It went live, so I had to put something on. I see my voice is so relaxing, I guess. Okay. So these are the stats. I achieved something in this month of work, and I mostly didn't waste my time on streams. So I was streaming the work I will do anyways. And I'd say for such a niche thing to stream, having 22 followers by the end of the first month is a huge success, given that I had 0 promotion of myself. Actually, I have 20 followers. I have 1 follower that I have my own account, and 1 follower that I asked my friend to do, and 20 other people, like actual people following me, and like at least 10 of them were typing in the chat at some point. So I actually quite happy with what is happening here on stream. So everyone who is here, if you're following, I appreciate your support incredibly a lot. Yes, type 1 if you are a bot. Okay. But yes, like I didn't know what to expect when I started. I didn't know if anyone would be interested, but I figured out. It seems like some people are. I see. No one's in the chat. I'm not big enough to do one in the chat thing. When I will have 8 viewers, then I can do this. Okay, sure. So our song is being prepared. We are very close, it seems. Claude is thinking. Okay. Classic overworld theme transposed to octaves below the standard Arduino Was? Okay. Working range, all 8 nodes at, okay. Okay, let's try it, let's see. So, where are we? Here. Remove this and that and add, what have you done? Whatever. What? Why is Claude changing the way it gives me arrays every request? Like, what? What? What are you doing? Hertz and SMB durations. Okay. Let's see. I think it sounds nice because the song was designed to be played in a single tone. I think we can play single tone songs much better than we can not actually single tone songs. Okay, let's just go with this. Okay, let's say Arduino, even though I'm not using Arduino right now. Songs for Arduino. Okay, let's see. Concert begins. Oh my god, what the hell? Brother. Okay. Oh, now I know why it's called melody. I think the Claude just copies the Arduino examples. Okay, I see, sure. What the hell is this side? What the hell is this song? For melody followed by duration, sure. Followed by duration. 4, 8, and duration in what? In milliseconds? Quarter note and 18ths and 16ths. What do you mean? Okay, let's give Claude the work. So other song requests in the chat. So what song would we do next? I actually liked Ode to Joy. Can you make a longer version for Ode to Joy? While we wait for other requests. So any other questions, any other topics for discussion? What would you like to talk about? If anyone wants to talk about anything, in the chat. So this is done. Let's see what I opened as well. So this is our journey through the project on our Excalibur. This is quite a mess actually. Where is the beginning and where is the end? Who knows? Right. This is what we've been through. Like, show one picture of my depression, right? Okay. So streams in pictures. Okay. So we were discussing stuff for sure. Okay. So anything else interesting I can show you? Are you willing to explain me your debug implementation for your data logging? It was quite interesting. but I haven't seen the total overview. Might be a lot, so maybe over at that time. Actually, it's not finished yet, but it will be incredibly powerful. Actually, we'll show you what I've done on stream when we get the next song going, because it takes so much time. We will listen to this song and I will try to explain it while we wait for the next song to be ready. So let's first listen to a longer version of Ode to Joy. Oh, we will have 3 more. I don't know what it's called. 3 more something. 3 more something of Ode to Joy. 60 more percent of the song. Okay. Okay, so let's run it. It's finished. It's done. Is it in the same array? Can I reuse it? I can. Okay, very nice. So let's do it. Here and here. And let's put it like this, and the microphone. Very nice. Okay. So, any other song requests while we wait? Like, what can I think of as a song request for such a thing? Do I have any classic I would like to play on the motor tonight? Can we do something more action-packed? Actually, any other song ideas we can play on the motor? When you don't have ideas, ask AI. Or do I have any songs ideas? I'm not sure. Okay. Tetris theme, Zelda theme. I haven't played Zelda actually at all. Like I have played 0 Zelda games. Undertale. I didn't play Undertale as well. I didn't play Final Fantasy as well. And I didn't play Pokemon as well. But I watched Pokemon. I was a big fan of a show when I was a child. But what is the Pokemon's theme for Elise? I have no idea. Imperial March. Oh, this is a classic, sure. Actually, this is a classic as well. I haven't watched Game of Thrones as well, so people will now see how uncultured I am. Oh, Harry Potter is also actually a very good one. Now I'm gonna give you actually I actually like this. Gonna give you up. Not gonna let you down. Not gonna run around and desert you rather. Da, da, da. And Imperial March and Harry Potter. Mr. Potter. Main theme. How is the word theme song spelled? And a Pokemon song. Pokemon theme as well. Okay, we have made quite a list. So now let's talk debugging, shall we? Because this will take a while for sure. So for me to actually show off my debug implementation, I need to do what? I actually don't need to do anything. I just need to flash a different firmware. So let's switch it and see. Start control, so let's flash it. Okay, so let me kill my debugger. Never gonna go around, don't desert you. Here, so let's flash. And also let's open our Python side, which is hidden somewhere. Let me look for it. Give me a moment. Here and here and here and here and nope, wrong location, and here, and I do it off screen, of course, and run. So our motor will start spinning, hopefully, this motor. And what we will see is that I need to still open stuff here. So examples of what is currently implemented. I was working actually until 4 in the morning. I said yesterday on stream that when I finished it like at 11 that I need to fix my sleeping schedule, and I was working until 4 in the morning. I was just writing code. Damn, son. And I have a plane on Saturday at 6 in the morning, so I don't think I will sleep on Sunday at all. Sounds like a good night. It actually was. So here we are, and actually let me show you some very nice stuff. So where are we? We need to go to examples. We have quite a few of them. Do I need to make it bigger? I definitely do. Let's do it again. So Python, actually, yes, Python example, scan COM ports. Let's see what we have. Or we don't have anything because I forgot to attach our USB UART. One moment. The hell is here? Wrong side. Now we're gonna round around and desert you. Okay. So we are attached. So let's see what COM port is. COM port is 6. Very nice, because this is default. So let's do ls again. And we actually don't need code at all. So first, let me show you the verification I did, the identification rather. So, and I think you don't see what I'm typing. So let's move the motor to the side. And this here, something is happening on screen for sure. Something is happening. So we were working yesterday on parameters. So now how it's work is that I can example com read all parameters. And I have all parameters that are registered in my firmware. And how do I do the registration is I just simply call the registration function. And that's all. Like I create a parameter, which looks like this, and I register it. And now I have the values that are set here. And what I can do is I can simply do, let me move this to the side with this and open this bigger. Oh my God, close, close. Oh my God, bloody markdown. Yeah, so let's clear stuff. Let's ls again, and now let's say Python example com write parameter, and I say ID. Actually, we need to call this first, and now Python example com write parameter, and let's say ID will be 1 and the value will be 23.72. And let's see here in the debug view, it just bam and didn't work. Why? Oh, I forgot the type, sure. And type is F32. Now it works. So the value is here, and I typed it here, and I knew what the description is from here. And the point is that in this code, there is no longer a point when it needs to be done manually. So there is no other code but just the parameter creation and registration. Nothing else. So the update of the parameter value is done in the software, in the firmware, in the protocol itself. And this part can also be like flexible. You can change the order of them, and you will still be able to read the parameters to find what you need because you know the description of it, and to write it. So this is the first thing, but it is not the only thing. So we also have a different functionality for Python example com read all buffers, and I have all the registered buffers, their description, and I can save any of them to CSV, like rather all of them. And then I also have a new thing that wasn't done on stream yesterday, but was done off stream after the stream. Yes. So it's Python example com read all requests, and it says all the requests are parameters stored in Flash. The structures that describe them, yes. It can be also done in RAM if needed. But this value parameter stores a pointer to the value that it needs to update. It doesn't store the value itself, because, for example, for motor controller, I would like to store like a target inside the motor struct, and I don't want to have a parameter that I will put into the motor struct, because then if you need to change the parameter of what you define as parameter, you will need to change the motor struct each time. Instead of this is a separate parameter that is stored in the object you defined as your control object, and the parameter just stores a pointer to this field. So you will store a pointer to, for example, current target speed, current targets in the parameter. Oh no, the data is not retained after the reboot. This is the next thing I will do, is saving the calibration values and like actively used values in the memory. But as you can see, I registered 2 requests, and the requests are just also objects that call a function. That just call a function when request is called. And so look at the LED here. Actually, don't look at the LED. No, look at the LED. Because I have a Python example com, it will be, actually I forgot the name, ls execute. Okay, Python example com execute, and ID will be, actually no, let's first read them. I have one I closed. Sure. So let's do first example com read all requests. So we have a description of every request that is registered and the ID of them. And now that we know them, we can do the call example com execute request, and the ID will be let's turn it off, let's turn it on, boom, and then let's turn it off, boom, and let's turn it on, boom, and let's turn it off, boom. So I can write complicated command chains from my Python for the protocol, and I can do like whole GUI applications to control the motors. So I can literally now create robots controls so that I can send commands for my drivers to do some meaningful work, to follow trajectories and stuff. And like it's all done here. And the most important part and the most impressive part is this, it's all self-documenting. So I can literally make a Python script that will assemble this into an object dynamically. And now I will be able to call an object like motor speed, like say this, and this will work. This is like the end goal, to be able to do it like this. That you say like scan something, and then it creates your own object, and you can run it like this. And you're like, oh, ooh. And also I have debug streams and debug buffers, so I will be able to stream data into CSV, into like graph plotter or something. Is this configured as an interrupt, or are you polling for data? It is interrupt based, but the implementation for each, it is implemented in a way that is protocol independent. So there is a generic part, which is stored in here. Let me show you. No, it's not here, it's here. So this is a generic part. So all the data structures, all the registration is happening here. And this is completely generic. It doesn't need to be connected to any protocol. It doesn't need to be UART, it doesn't need to be USB, it doesn't need to be anything. And for every of your interfaces, you can make also an interface version. And currently I work with UART because this is what is implemented, but you can do like the interface side of it for every interface. So you can use absolutely the same semantic of the debug parameters, of the debug values of everything, if you implement these two files. So if you implement these two files and everything else is supposed to work. You also need to implement the Python file as well. But the core of it stays the same. So I can, like with like few days of work in the future, change this to be, for example, to use CAN as a way to send data, or then to use USB as a way to send data, or to use something like Ethercat as a way to send data. So because before we started the redesign a week ago, it was very highly interlocked with UART. And I decided, no, I don't want this to be interlocked with UART. I would like this to be a generic tool. And this is what we were redesigning towards, like for this week. And yes, a lot of work has been done. And like it's kind of close to be finished, but it's also not really. It's like 70% done roughly. But yes, I really, really, really like how it looks now. I really like the concept I made up, that everything works the same. We need to register every type of object. So every type of object has description that have lengths that can be different. You can pull the data on your master side. You can update the data in whatever way you want. And the slave always self-describable. So you always know what is going on the slave at any moment. You can understand this. And you can read parameters. You can write parameters. You can read logs. You have buffers to store some particular data. You have ring buffers. If, for example, you run a control system, control loop that, for example, overshoots for like current or something. So it's very powerful. I love it a lot. You looking into CanFD or normal CAN? I have a CanFD transceiver here installed. This little bugger. So CanFD is present, but CanFD is not implemented. But I hope I will come to this at some point, probably sooner rather than later. But yes, CanFD is one of the protocols I would like to put my debug protocol onto at some point. Yep. So let's see if Claude finished thinking. Out blocked by content filter policy. Was? Why was my request blocked? What have I done? Am I banned now? Uh-oh. Uh-oh. You wanna hear the song? No. Not today. You actually ask, Mr. Das, you actually asked me about the CAN for the second time. Why are you asking? Anything particular I should be worried about? And here. So, Mr. Claude, why have you blocked my request? Tell me. Tell me. Now. Tell me now. Please. Why is it taking so long? Was the question so hard? Oh my god. Anyways, any other questions in the chat for now? Let's see if any changes were made to the code by Claude. Where is it? It's here. Remove this and open. Okay. That. Let's see. Super Mario Bros. Lord of the Rings. Nyan Cat. Ode to Joy. No, nothing new is added. Okay. Unfortunate. And Khan, or no, not Khan, but rather Claude ignores me. Normal Khan has a maximum of 1 megabit per second, so I was curious if your implementation would be working. It will. It is not time critical. No, the only time critical part is the streams. So streams are supposed to stream data at an interval, but you can always manage this by just changing the update period you have to whatever your interface can support. And I have a lot of experience Khan can open, so was interested in it. Oh, I see. I think it can be put on Khan. I'm not 100% sure, given that I never worked with Khan, but I think it can eventually. You just need to write like these 3 files, like 2 files actually. The third one is optional. You can have your master side implemented in whatever language you want. Like the master side is not critical at all. You can do it in Python, you can do it in C++, you can do it in like Ruby on Rails if you want. Like do what you want, do what you must rather. Do what you must. Actually, what is that? So Claude blocked me and doesn't want to answer. Please, pretty please, Mr. Claude. Mr. Claude, can you please answer my question? So, any other ideas? So what should we do? Let's listen to songs we already have available while Claude is ignoring us. Build configuration, bring up, and let's see. What song do we have as active and Ode to Joy? Let's listen to this. Da, 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 da. Da, 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 da. Da, 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 da. Da, 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 da. That was my intervention into songs. So. Okay, and the concert keeps going. I think what is wipe coding. Maybe it is wipe coding. Who knows? Who knows? Our Nyan cut. So let's remove this one. We only have 4 songs. No. No. I'm scared for my I'm scared for my tokens. I'm scared. Okay. Next one. Hmm. Okay. Oh, I know the song I would like to play. I know the song actually. I hope Claude finishes because I know this song. Oh my god. Oh my god. I know the song that we will play last on today's stream. I know, I know. Let's play our Super Mario Bros. The best one we have so far. You will never guess this song. I will actually do a Claude request off screen. Again! Not again! Claude, brother! Okay, let's actually make a request. Add notes for... I'm making the request. I'm making the request off screen. Off screen. That is. Okay, I made the request because I think, given that people don't really want to provide any requests, we might as well start closing the stream for today and for the rest of the months, the next months, for quite a while actually. For quite a while, because this is goodbye. For a while. for a while. Oh, I also now know another song. Well, if Claude was faster about writing songs, I would have actually. Now I started getting the ideas in my head. When it's too late to apologize. Too late. Okay, but we have to do something for for some time while Claude is like thinking. What else can we do? What else can we do? We can discuss plans. We can discuss plans. So, I will be away for. ChatGPT, give me a list of 100 songs. Yeah. So, the plans. I will leave and I will not stream when I'm gone. And I hope that when I return, I will have 25 followers. Pretty please. Or not, of course. Or not, who knows, who knows. Then, when I return, the debug protocol will be finished. I hope I will finish the motor controller implementation as well. I think I will take a motor controller with me to my job site so that I can finish enough time, because I will have a normal 9 to 5 there for a month. Well, how normal? Like a normal 9 to 5 when you like go to the site and you live in your employer's house and you work in their lab. 9 to 5 kind of thing, you know? Then what happened? What happened to my goal? Oh, someone followed. Thank you. Someone, but I don't know, but I don't see your name. Who followed? Who followed? Whoever followed, thank you so much. I appreciate it a lot. I don't know why notification is not anywhere, actually. It's not on any platform. But whoever followed, thank you so much. So, then I return with hopefully something finished, and we will work on the inverted pendulum. So we will develop an inverted pendulum project. We'll probably do a stationary one that just rotates, the one that swings around the rotational base. Actually, let me Google inverted pendulum stationary. I know that this is an incorrect order of words, but what I mean is, like, this is a linear guide, but there is a rotational guide, like this, so that it spins around, and we have a way, like a need to stabilize this in an upright position. So this will be the project that we will work on stream from scratch when I return. And also for anyone who may be interested, I also will try to write my own simulator, physical simulator in C++. To not use MATLAB. MATLAB is great and all, but MATLAB is also very expensive. Very, very expensive, incredibly so. And I'm not so rich. So I will write a small C++ OpenGL simulator to simulate this before we implement this in real life, and then we will implement it, and then we will have a GUI that will show us parameters and numbers of the inverted pendulum when we will have it working. So it will be an amazing project. So everyone should tune in and follow to see more. Okay, what the hell? Brother. What? No! Do I have any money actually on Claude? Let me check. No final song? No. File. Help settings. Hold on. Settings. Billing. And do I have a usage rather? Do I have any money here? Oh, I do have some money. I have €1. Will €1 be enough for a final song? Let's see. €1 and a dream. €1 and a dream. Please finish. Okay. I actually have €1.65. So, a rich bitch. So, this will be the project. We will have an inverted pendulum. Like this, that we will try to put outright. We will have a physics simulator. We will have our motor driver finished. Driver, and they will be all connected. And we will have this controlling this to work like that. This will be a huge project that I'd say will take me a month, maybe 2 months, but should be very fun and also should be very educational for anyone willing. Okay, I think the final song is ready. 6 months? No, I don't think I'm so bad. I don't think I'm so stupid. No. 2 months. 2 months is a bet. When I return, it will take me 2 months. Well, that highly depends if I will have a client again, because like from this client, I hope I will make some money so that I can be a bozo and don't have a client for a few months again and just spend all the time coding this, designing this. But that will highly depend. Depend on how much you want to simulate and how well it actually translates into the real world. I think I know kinda not fully what I'm talking about because I kinda did actually, if you want, I can show you, because I kinda did the similar thing when I was a student. Actually, this is a project I'm most proud of. Let me actually open it. Let me flex before I go for a month. Let me flex a bit. I did this project when I was like 22, I guess. Where is it? Or maybe 23. Oh my god. Where is it? How do I even use this? One moment. Oh, I see. Now I see. So, this is a project I'm most proud of. I hope it will load also. Please, can you load? Load. I dare you to load. What is going on? Why isn't it working? Oh, it works. It kind of works. So when I was 23-year-old in Belarus, I was very poor, so I didn't have enough money. This thing's supposed to do it like by itself. So the thing is that this robot can balance on both sides, and it should have been able to get upright against the wall itself. But given that I was poor, I didn't have money for a strong enough motor, so my motor wasn't strong enough to make it go up. So I had to like press it with my leg for this to go up. But when you help it a bit, it works. And this was like a very nice project to do. I enjoyed it a lot. What language you're gonna use for simulator? Because it depends on low levels languages for real hardware. I will use C++ and OpenGL for the simulator. I'm proud of it. Not proud of it, I'm sure of it. So we will make a very, very small simulator that will be not general purpose, but rather suited only for inverted pendulum, and then we will see how it will go. So maybe people but rather underestimate the complexity of what is going on, given that you probably expect me to do something crazy, but I think I will do something rather rather simple or rather simplified, and then depending on the result, we will see how like bad or good it will go, and we will decide if we will do it like more complicated or not, or something. But yes, I do have some experience with control systems, as you can see. But yes, this was a very nice project to work on. I enjoyed myself a lot. So now, this will be a mess for like 2 to 6 months, depending on who you ask to estimate this mess. And now let's play our final song of the day before I go. And I will also hide what song we are playing. So, what is the song? Let me actually edit. One moment. And I'm gonna give you up, and I'm gonna turn around and desert you. Yes, this one. Yes. And here. So, I'm flashing it. Are you ready? Okay. Sorry. Now, the final song of the day is starting now.